We are in section 2.2, Techniques of Differentiation. Using the definition to calculate the derivative is a very long and tedious process. We had to combine like terms, distribute, multiply things out, things needed to reduce, and so it took a long time. So we now will develop rules that will make calculating the derivative much easier. So first off is the notation for the derivative. Like we saw earlier in the last section, it was f prime of x was the only one that we were using, but there are different ways to write this, and so we need to make sure that we're okay with f prime of x, dy dx, d dx, f of x, which is telling us to take the derivative, a capital D with a little sub x, which is another way to say taking the derivative. The dy dx notation for the derivative is read the derivative of y with respect to x. And this one's a big one to know, especially as we move through chapter 2 and into chapters 3 and 4 also. So the derivative of a constant function, so d dx of c, just a number, a constant, it could be pi, it could be a fraction, decimal, positive, negative, 0, anything, is just equal to 0. Then we have our power rule, which says if n is any real number, then the derivative of x to the n, if you notice that exponent that we have here at n comes out in front, and you actually subtract 1 from that power. The next thing that we have is the constant multiple rule. It says if c is a constant and f is a differentiable function, then the derivative of c times f of x is just the derivative of f of x times c, that constant out in front. And I wrote down this rule in addition to being used with the power rule. And so if you have c times x to the nth power, it's going to be c times n times x to the n minus 1. So the examples right below. We have f of x equals negative 2. Then find f prime of x. So make sure to put down an f prime, something to tell me that you're taking a derivative. Just putting down the answer of 0, I don't know what you're telling me or what you're discussing. So make sure you put down that it is a derivative. It's not the intercept, or it's not the slope or anything like that. So we have f prime of x is equal to 0. The next example says if f of x equals negative 3x, then find dy dx. So dy dx is equal to, and for this, we just have, if you think about it as exponent of 1, and so we'd have negative 3 times 1 x to the 1 minus 1 using that power rule. And this just simplifies to being negative 3 x to the 0, or just negative 3. The next example, we have f of t equals the square root of t. Then find dy dt. So first off, notice that this time instead of dy dx, we have it dy dt. It's with relationship to t, which is the variable that we have here. So this function, f of t, is the same thing as t to the 1/2 power. And so needing to rewrite, anytime you have a root, to rewrite it as an exponential function instead. And so it should be rational, and it's 1 over 2 for the square root. And so working this out, again, that power, the 1/2, gets moved out in front, and then we subtract 1 from that exponent. So we're going to have 1/2 t to the 1/2 minus 1. So this is going to be 1/2 t to the negative 1/2. And then from here, remember, negative 1/2 is going to move to the denominator. So we're going to have 1 over 2 t to the positive 1/2. And then rewriting this as a root is going to be 1 over 2 square root of t. So again, this is going to give us our function for the derivative. This is much faster than using the difference quotient and taking the limit of that. So the next set of rules that we have is the sum and difference rules. This says if f and g are both differentiable, then the derivative of f of x plus or minus g of x is equal to the derivative of each of those terms. So we have examples right below. First one says find the derivative of each function, and we have y equals 3x to the fourth minus 2x cubed plus 5x minus 7. And so we need to find y prime. Again, you can write this as dy dx also. There's other ways to write saying that you're taking a derivative. And so we're just going to go term by term by term, and that's exactly what the sum and difference rule says up above. So we're going to have 3 times 4x to that, and I'm going to subtract 1 from that exponent, which is 3, minus 2 times 3x to the, subtracting 1 would be to the second, plus 5 times 1 x to the 0, because again, remember that's to the first, minus, and then the derivative of 7 is just a constant, which is just 0. 3 times 4 is 12x to the third, minus 6x squared, plus 5. And this would be the derivative function that we have. And as you get more used to this, you'll start doing like the 3 times 4 in your head and just writing 12 and kind of skipping that first step that I wrote. But until you get there and you feel more comfortable with this, make sure to show those steps to make sure that you don't make any mistakes. Part B, I cannot take the derivative of it like this. I can only take the derivative of the power rule, which says a variable raised to a power, not a quantity. This is 2x minus 1 raised to a power. So I'm going to multiply this out. So I have 2x minus 1 times 2x minus 1. And so this function is the same thing as having 4x squared minus 4x plus 1. And so taking our derivative, I'm going to have 4 times 2x to the first minus 4x to the first is just going to be a minus 4. And then derivative of 1 is 0. So from here we get 8x minus 4. And so that would be the derivative function that we have, our f prime of x. So we have 2 more on the next page. So C says p of t equals t cubed plus 2 square root t over t. And so for this I need to also do some work before I can take the derivative. So I do not have any rules yet for dealing with quotients or dealing with fractions where the variable is in the numerator and the denominator. So rewriting this is the same thing as t cubed over t plus 2 square root of t all over t. And so this will simplify to just t squared plus, and for this we have the exponent rules that we had from before. So this is t to the 1/2 over t to the first. And so you would subtract your powers. So you have 1/2 minus 1, which is going to be t to the negative 1/2. And so we have 2t to the negative 1/2. Remember, we have not yet taken the derivative. All we did was rewrite our function in a way that we can take the derivative and use that power rule. So now I'm going to write p prime of t, so that way we know that we're now taking the derivative. And the derivative of our first term, which is t squared, is going to be 2t to the first power plus 2 times, and then that exponent's negative 1/2, so times negative 1/2, t to the negative 1/2 minus 1. We have 2t. Our 2's are going to reduce here. We have a minus sign now, and I get t to the negative 3 over 2. Since this is negative, it will move to the denominator. So we have 1 over t to the 3 over 2. So this is going to be 2t minus 1 over, and then to rewrite t to the 3/2, this is going to be the square root of t to the third power. And so that would be our derivative function. Part D says y equals 3x to the fifth minus 5 times the square root of x plus 1 over x. So again, I'm going to rewrite this before I even begin taking a derivative. And so this is going to be 3x to the fifth minus 5x to the 1/2 plus x to the negative first. And so to take our derivative, I'm going to go ahead and use dy dx equals, we have 3 times 5 x to the fourth minus 5 times 1/2 x to the 1/2 minus 1, or negative 1/2. Taking the derivative of x to the negative first, we have minus 1 x to the negative 1 minus 1. And I wrote that one out so you can see that because we haven't had negative exponents yet in our examples. And so from here, we have 15x to the fourth minus 5 over 2 square root of x, since it would move to the denominator because it's a negative, and x to the 1/2 is the square root of x. And then we have minus x to the negative second, and it would move also to the denominator, so 1 over x squared. The next example that we have says, at what points on the graph of our function f of x equals x cubed plus 6x squared plus 21x plus 2 is the slope of the tangent line equal to 9? And so the first thing is it does ask for points, which means we're asked to find x, y. And then the slope of the tangent line is going to be our derivative. So f prime of x would be equal to 9. And so in order to figure this answer out, we need to first find the derivative of our function f of x. So f prime of x, which would be equal to, and I'm going to try to do this one a little bit faster in terms of writing it down and kind of doing some of the little math parts in my head. And so the first thing we have is going to be taking the derivative of x cubed, would be 3x squared. Then we have plus 6x squared is going to now be 2 times 6, or 12, x to the first power. The derivative of 21x would just be 21, and the derivative of 2 is just 0. And so I need to set this equal to 9, as it was wanting us to do here. So setting this equal to 9. And again, remember, when you have a quadratic or anything with a higher power, one side needs to be 0. So I am going to subtract 9 on both sides. So we have 3x squared plus 12x plus 12 equals 0. From here you can factor out a 3, and we have 3 times parentheses x squared plus 4x plus 4 equals 0, which does factor, especially using your mental math and just the guess and check method. This is going to be x plus 2, or you can write it as x plus 2 squared. But from here, solving this, the only factor that we have is x plus 2 equals 0, which means x equals negative 2. And so now we have our x value, but it did ask for a point. So we have x. We now need to find y. In order to find y, this is going to be equal to f of x. So we need to substitute this back into our original equation, which was x cubed plus 6x squared plus 21x plus 2. And so f of negative 2, substituting negative 2 to the third, 6 times negative 2 squared, 21 times negative 2 plus 2. That is going to work out to be negative 24. And so our ordered pair, or our point, is going to be negative 2 comma negative 24. The next example, right below this, says at what x value on the graph f of x equals x cubed plus 2x squared plus x is the tangent line horizontal. So horizontal tangent line means that our slope is equal to 0, and our slope of the tangent line is going to be where f prime of x is equal to 0. The derivative f prime of x is equal to 3x squared for the first term, then 2x squared, taking the derivative, would be 4x. The derivative of just x would be 1. And so this is our derivative, and to figure out where it's horizontal, we're going to set this equal to 0. And in order to do this, we need to factor. I'm going to try the guess and check method, and the only things that multiply to 1 would be 1. 3x squared would be 3x, and x, everything is positive, so I'll put pluses here, and then checking to make sure that is done correctly, which it is, and then setting each of these factors equal to 0. So we get x equals negative 1/3 and x equals negative 1. And this problem is only asking for those x values and not points. But if you needed to find that order pair, you can substitute this back into that original given equation f of x for the y values. Right below this, we have marginal analysis. It says in economics, it's important to study the rate of change of a variable such as cost, revenue, and profit. Since the derivative of a function gives the rate of change of that function, the marginal cost or revenue or profit is found by taking the derivative of the cost or revenue or profit function. Marginal cost, and again, of revenue or profit, is approximately the cost or revenue or profit of producing one more unit. So the cost or profit or revenue of producing one additional unit. And again, this is marginal cost, marginal revenue, or marginal profit. Also, remember that profit is equal to revenue minus cost, and that the demand function relates the number of units of an item that consumers are willing to purchase at a price P. And so we can say revenue equals that quantity times the price, or Q times the price, which we can also say is our demand function. The example right below we have says, suppose that the total cost in hundreds of dollars to purchase X 100 ounces of cheese is given by C of X equals 5x cubed minus 10x squared plus 75. Find and interpret the marginal cost for X equals 10. And so this would be 100 ounces of cheese, since that was what X is defined as up above. Marginal cost means that we need to find that derivative, so we need to find C prime of X. And so C prime of X is going to be equal to 15x squared minus, and then taking the derivative of the second term, which is 10x squared, we're going to have 20x to the first, and then the derivative of 75 would just be 0. This is our marginal cost function, and we're asked to find this when x is equal to 10, so I am going to substitute in 10 for x. From here, working this out, 15 times 10 squared minus 20 times 10 equals 1,300. And again, this is a cost, and cost up above is given in hundreds of dollars. So again, you can rewrite this, and sounds kind of weird to say $1,300. So I'm going to say 1,300, and then 100 has 2 zeros, so add 2 more zeros, or you can think of it as multiplied by 100 to get that value. So we can say, or $130,000. So this would be our answer. It does also ask for us to interpret this, and so we can say after 1,000 ounces of cheese have been produced, the cost of producing one more, and it's not ounce because we're measuring stuff in 100 ounces, so one more 100 ounces of cheese is $130,000. We have another example at the top of the next page that I'm going to go ahead and circle, and we're going to look at this one together in class. Right below this, we have relative and percentage rates of change. So it says the relative rate of change of a quantity Q of X with respect to X is given by the ratio. This is the derivative of Q divided by Q. And then the corresponding percentage rate of change of Q of X with respect to X is 100% times that, or 100 times that. And that would give us a percentage. So the example right below says Gary's starting salary is $45,000 and he gets a raise of $2,000 each year. A says express the percentage rate of change of Gary's salary as a function of time. And so I'm going to go ahead and use a G for Gary. And so his base salary, his starting salary is $45,000. Plus he gets a raise of $2,000 for each year. And I'll say each year we'll call T. So 2,000 times T. So for after his first year, he'll get the 45,000 plus the 2,000 times 1, so 47,000, and so on. And so in order to do this, we need to take a derivative for our percentage rate of change. And so the percentage rate of change that we have is going to be given in the box right above. And so we have G prime of T for this problem, and this is just going to be 2,000. Since 45,000 is just a constant and the derivative of 2,000 T is 2,000. And so it's going to be our derivative, which is 2,000, divided by our function, which is 4,500, plus 2,000 T times 100. And again, if you wanted to throw that percentage on there, symbol on there, you definitely can. Part B says, at what percentage rate will Gary's salary be increasing after 1 year? So at 1 year, T would be equal to 1, and so we're going to have 2,000 divided by 45,000 plus 2,000 times 1, and then again times that 100, and then we'll add the percent. And so working this out, we get 4.26%.